Welcome to This Explainer. Right now, across the financial sector, from modernizing loan origination systems to, retail banking customer service, generative AI is dominating boardroom discussions. And it is, without a doubt, transforming how business operates. But as executives rush to deploy these capabilities, there's a critical, silent variable that's getting overlooked: the hidden economics of AI. Today, we're taking a very measured, analytical look at the underlying costs of artificial intelligence. Because while the tech is incredibly powerful, if you fail to understand its pricing structures, especially in high-volume production environments, you can actually turn a strategic advantage into a severe margin liability. So we really need to ask a fundamental question right up front. Is your AI strategy actually economically viable? Look, it's easy to get caught up in the industry hype. Every vendor out there is promising unprecedented efficiency. But the contrarian reality, and frankly the one many enterprise AI initiatives are discovering the hard way right now, is that ignoring unit economics leads directly to unpredictable costs and a really poor ROI. You just cannot scale intelligence if the financial model underneath it is fundamentally broken. In our executive briefing today, we're going to follow a top-down, hypothesis-driven structure. We'll unpack the AI ROI illusion, decode the reality of token economics, identify the architecture of waste hiding in your systems, and finally, deliver the optimization strategies and the efficient hierarchy you need to actually scale profitably. Let's jump right into part one, the AI ROI illusion. This is exactly where so many well-intentioned digital transformation and fintech initiatives begin to go off the rails. There's this common institutional mistake of treating generative AI as the default solution for all data challenges. We see organizations rushing into large language model implementations without really understanding how the pricing works at enterprise scale. I mean, think about it. When you apply a highly complex, expensive large language model to a simple, deterministic task, like basic KYC document routing or standard compliance checks, the result is inevitable. You're going to experience unpredictable costs, severe budget overruns, and ultimately a very poor ROI. It's a direct path to margin erosion. You're taking what should be an operational efficiency and turning it into a massive fiscal drain. So to understand exactly why these costs spiral out of control, we really need to examine the mechanism driving the billing. Let's unpack AI token economics. The crucial point here is understanding the token. Now, this isn't just some abstract technical concept. It is literally your fundamental variable expense. A token is a unit of text used for AI billing. And here's the trap that catches a lot of folks. You are billed for both the input, meaning the prompts and data you send to the model, and the output, which is the model's response. Your cost per request depends on input size, output length, and the computational complexity of the model itself. Because of these variables, AI costs scale non-linearly. If your institution is processing massive datasets, say scraping thousands of alternative credit data points per applicant, those fractions of a cent compound aggressively into massive cloud computing bills. Let's ground this abstract concept into a tangible formula. One token is roughly 3/4 of a word. So 1,000 tokens equals about 750 words. As a financial leader, you need to visualize this math every single time your systems parse a 50-page credit agreement, summarize an intricate compliance document, or generate a customized customer support response. Every word sent into the model and every word received back from it translates directly into an invoice line item. When you multiply that across millions of daily transactions, the financial implications are absolutely staggering. Navigating how vendors actually charge you is essential. There are 4 distinct pricing models you really must manage. First, there's pay-per-token, which is standard for usage-based LLMs. Remember, higher-end, more capable models cost significantly more per token. Second, subscription pricing. This offers monthly limits, but often carries steep overage charges hidden right there in the fine print. Third, we have compute-based pricing, which is tied to GPU or CPU usage for your own custom deployments. And finally, fine-tuning, which carries upfront customization costs, plus those ongoing inference costs we just talked about. Understanding this marketplace structure isn't just an IT issue. It is an absolutely critical component of vendor risk management. But pricing models alone don't explain the budget overruns. The true culprit is often found in how the technology is actually deployed. Let's look at the architecture of waste. There are 5 common operational missteps that quietly drain financial resources. First, overusing large language models for simple tasks that honestly don't even require generative AI. Second, inefficient token usage. Verbose system prompts and unnecessarily long responses consistently drive up that baseline cost per request. Third is poor AI architecture and routing. If you don't separate simple from complex tasks, every single routine balancing query ends up hitting your most expensive computational models. Fourth, lacking a caching strategy. This means you're paying premium rates to compute the exact same answers to the exact same questions over and over again. And fifth, real-time overuse. Not all workflows need real-time AI. Batch processing overnight risk assessments or portfolio rebalancing is vastly more cost-effective. Just look at the stark contrast between a wasteful deployment and an optimized one. An inefficient architecture drives your baseline costs higher with every single transaction, essentially punishing you for scaling. Conversely, an optimized strategy utilizes caching for frequent queries and embeddings. By simply intercepting and reusing frequent outputs at the architectural level, you drastically reduce repeated API calls to the vendor. It's a fundamental architectural shift, and it completely protects your profitability as transaction volume grows. Recognizing the waste is only half the battle, though. Let's shift our focus to the strategic solutions. Optimization strategies for lowering AI costs. Establishing a disciplined, tiered approach to AI adoption is completely non-negotiable. Step 1. Start with analytics first. Invest in business intelligence and data visibility before indiscriminately applying artificial intelligence. You'd be surprised. Many apparent AI problems can actually be solved with simple, well-engineered dashboards. Step 2. Use traditional machine learning second. The source material highlights a really critical truth for financial services here. For structured problems like credit scoring, fraud detection, or transaction categorization, traditional ML is not only vastly more cost-effective, but it's faster, more accurate, and far more reliable than a hallucination-prone generative AI model. Finally, step 3, build hybrid architectures. These seamlessly combine rules-based systems, traditional ML, and selective generative AI, intelligently routing each task to the cheapest capable engine. Right-sizing your models and reducing token usage requires rigorous institutional governance. You have to track your AI costs continuously across 3 specific unit metrics: cost per request, cost per user, and cost per business outcome. If you aren't monitoring these metrics at the C-suite level, if you don't understand exactly how your AI spend impacts your cost per funded loan or your overall customer acquisition cost, your operational expenses will inevitably drift. You cannot optimize what you do not measure, and in algorithmic finance, unmeasured costs compound rapidly. This all requires a core strategic framework. So let's look at the ultimate guide to right-sizing your enterprise models, the efficient AI hierarchy. This framework perfectly illustrates how chief data officers and CIOs must right-size their technology stack. At the base, you have analytics, the lowest cost, perfect for deterministic reporting, and operational dashboards. Moving up to the middle, you have traditional machine learning, medium cost, highly effective, and robust for prediction and classification tasks like default risk modeling. Then at the very top is generative AI, the highest cost layer. Therefore, generative AI should be strictly gated and reserved for complex language and reasoning tasks where it uniquely provides scale. Use analytics first, apply machine learning second, and deploy Gen AI only when the margin absolutely justifies the compute. It's worth noting that the insights driving this analysis come directly from Belapore Analytics. Their entire focus is on this exact operational discipline: designing cost-efficient AI and ML solutions, optimizing enterprise token spend, and building scalable data systems. The goal is always to deliver measurable business value without runaway costs, ensuring that an institution's intelligence layer scales in a financially viable, predictable way. Before you authorize any new technology implementation, this single question must be your institution's ultimate governance filter. Is this the most cost-effective way to solve the problem? It forces a strategic pause. It demands analytical precision over vendor hype. It ensures that you aren't deploying an expensive, parameter-heavy language model to solve a problem that a simple rules-based engine could handle securely for a fraction of a cent. Ultimately, enterprise AI is not just a technology decision. It is fundamentally an economic one. The organizations that will establish a true competitive advantage in the financial sector are those that master these underlying unit economics. They understand opaque pricing models, they enforce strict cost control strategies, and they design highly resilient, efficient architectures. Because the future of financial AI isn't just intelligent, it is relentlessly efficient. So the question you really must ask your tech leadership tomorrow morning is this: are we scaling our intelligence, or are we just scaling our costs? Thank you for joining me for this explainer.